In this video, we'll be looking at trigonometric identities and using identities to solve some problems. So, this is my favorite part of the course. I get to use geometric shapes. Okay, so having been told this is a right angle triangle here, what's the opposite side, knowing that angle theta? Let's pretend we know what angle theta is. Let's say it's a number like 30 degrees, and we want to know the opposite side. Well, we would just take hypotenuse and multiply it by sine theta, whatever sine of theta is. And adjacent side would be basically cosine of theta multiplied by hypotenuse. So I write h cos theta. If I can write number between them, sine, that means with a multiply. Okay, so in this video, if you don't see any multiplication signs, that means they're multiply. So that's that. Now let's just go back to our good old Pythagorean theorem and put these values from this triangle in Pythagoras theorem. The hypotenuse squared should be same as the adjacent side here squared plus opposite side squared. So adjacent side square is h cos theta, all of it is squared, plus, notice the squares outside the bracket, and h sine theta squared, and I can distribute, because there's times and times here, I can write this as h square cos square theta, and I'm writing this next one as h square sine square theta. Okay, so these lines are the same. I can divide everything on both sides by h square. You could factorize h square out of these two terms, but I'm just going to divide everything by h square here. Alright, so we get cos square theta plus sine square theta equals to what? What's this? This is 1, right? So 1 equals to cos, cos square theta plus sine square theta. This is the most famous trigonometric identities you need to know in all cases, in all scenarios. So can be rearranged to tell us what cos of an angle is. If you want to know cos of an angle and you only know the sine of the angle, let's just say cos square is 1 minus sine square theta, and then you can take the square root of both sides. You say sine cos theta is 1 minus sine theta squared. Now you could have also rearranged it to sine, take that same equation here and write sine square equals to 1 minus cos square, and you can take the square root of both sides. Sine theta will be square root of 1 minus cos square theta. Alright, so that's one way of proving this identity. I have yet another way of proving. Alright, so this is neat. There is another identity here. This is we already used this identity before, actually, when we calculated the exact ratio of tan. We said here the opposite side is h times sine theta, and adjacent side is h times cos theta. So what the h's cancel away here, and that's why tan theta is always equals to sine theta over cos theta. Now, alright, this is also very useful and handy in many cases. So now here I'm rewriting the proof that I did at the beginning of the lecture for you. We went through this, I wrote this by hand for you, so you can use those identities there. In this question here, first of all, it's the same scenario. Opposite is hypotenuse multiplied by sine, and adjacent is hypotenuse times cos. Now let's draw another right angle line here. This is perpendicular to the hypotenuse, right? So if this angle is 90 degrees here, I'm talking about this angle is 90. So what's this angle going to be? Well, knowing that angle theta, this must be what is 180 minus 90 minus theta is just going to leave us as 90 minus theta. Okay, and that means that this angle here, because of the right angle there, must be theta as well, right? Okay, so knowing that, and I've gone ahead and called this side of the triangle h cos theta, so the bottom side of the triangle. Now think of this as the new hypotenuse here, like this little h here is the hypotenuse of this smaller rectangle triangle down here. So this cos, if I want to calculate this, this, this is adjacent side of that triangle with regard to this angle theta, right? Adjacent to theta, and its hypotenuse is h cos theta. So I need to multiply by yet another cos to figure out this length here, right? So I would have cos theta times another cos theta h. Alright, I can just put the h at the front. So really this was, h was in the middle, but I'm just writing it at the front. Alright, so what do I have here? Cos square, right? Alright, so let's check out what's going on in this little small triangle here. Is, look, just focusing on this triangle here, it's a right angle triangle, right? And its hypotenuse is now h sine theta rather than the original h that it was. So if I want to know the opposite side to this angle theta here, I can say I need to multiply this small h by sine theta, right? So small h times sine theta, but that small h is capital H sine theta multiplied by yet another theta. So I'm writing that here, sine theta. So these two give us what? This is the sine h times sine square, right? That's h sine square theta. And this is h cos square theta. Alright? So together, what do they add up to? They add up to the original h, right? So I could say h equals to h times cos theta equal plus h times sine theta. This is yet another proof, dividing both sides by h this time rather. Okay, so you understand what's happening here? This, I'm saying the original length was h, right? The original identity. So dividing everything by h over h is 1, and I will end up with cos theta plus sine theta, like so. So 1 equals to that identity there. This is yet another proof. Now, okay, so here's a colorful way of writing it. Here we go. So now let's use those to answer some problems. So in this question, we have angle 3 theta here. It doesn't matter that those angles are three the same. As long as they are the same, what is this going to add up to? It's going to add up to 1. Alright? So the answer there, as long as the two angles are the same, that's how it works. Now, how do I solve this problem? What's the common factor here? I can factor as a 5 out of this. So when I factor as a 5 out of that, I have 1 minus sine square. Does that ring a bell anytime? So what's 1 minus sine square? Look up here, rearrange that identity there. That is telling us inside the bracket we got a cos square. Alright, simplifying this expression is just rewriting it. Alright, so remember these two. So I could rewrite it like that. That's slightly simple. Now in this section, remember what's that in the denominator? How we wrote the original. Notice sine here has 2 theta in it and 2 theta in it. So that means when I rearrange the identity, you might notice that the denominator is simply cos. The root of that is just cos of 2 theta. All right, so make sure whatever is inside the bracket here for the sign goes inside the bracket for cos. All right, and then once this gets simplified further, it will be, I hope you've answered this already. In top left corner, we got the answer. And all right, so in this question, it's a proof question. They don't treat this as an equality sign. It means that you have to start with either left side and manipulate it to get to the right side. So don't use two sides at once. All right. What's top of the fraction? If you remember at the very in the first few chapters, we learned how to factorize. Like when you have a to the power of let's say I'm not let's say 4 here minus b to the power of 4, right? This is similarly a similar ratio to difference of two squares. I know we don't have the squares here, but we have powers of 4. So you inside the bracket you could say that's like let's say let's make a substitution here. Let's say a square uh, is just a, so that or rather let's say that capital A square is little a. So then a to the power of 4 will be little a to the power of 2, and b to the power of 4 will be little b to the power of 2. So then we could make that substitution here and say that this is like a minus b times by a plus b. Alright? So we can do the same. Maybe I should use S and C in that question there. So first you factorize it once, and you see that this situation. You can write it at the top of the fraction like so. Okay. So then you say what's cos square plus sine square? It's going to be 1. Alright. So that very first bracket cancels away to 1. 1 times the second bracket still same second bracket, right? Now you might be uh, you might be enticed to go ahead and factorize this again, but I wouldn't because I've done it before and it doesn't work out. So difference of those two squares doesn't work there. But we can do something else. We can write two separate fractions, okay? So we can just simplify this cos over cos and sine square, so cos square over cos square is a 1 and sine square over cos square is tan square, which is what we get. And the right hand side have to equate that identity there. Alright, so be careful here. Uh, Rewriting this is as another, dividing it into factorizing that doesn't help. Alright, so now in this question, we've been asked to look at these three graphs and can we say, alright, so remember acute angle, obtuse angle, reflex angle. I've made it nice and bold for you to recognize. So these graphs is saying that to work out the exact value sign, this is just the objective for you. So the question is that write this cos of theta is negative 3 over 5 and we want to find the reflex angle for that. So we're saying that where is this negative 3 over 5 as a triangle on this diagram? Well, because it says reflex, it means that it has to be over 180 degrees. It has to be either in its third quadrant or the fourth quadrant. It's clearly labeled. I've got an upside down reflex written there for you. I can't read this. So there is reflex, definition of reflex again. So the fact that it's negative, then hypotenuse is always positive. Alright, so don't take hypotenuse to be negative. That means that the minus sign belongs to the 3. Yeah. Alright, so the adjacent side of this triangle is minus 3 somewhere here, and we draw a triangle like so. Alright, so its adjacent side is this side. and this is 5. So famous Pythagorean triplet, you should know that the opposite side here is 4. But we're going to use minus 4 because the y values are negative in this quadrant. Okay, so it's saying write this, find the value of sine theta. Alright, so this is our theta here, and we're going to write sine of theta is equals to, read it from the triangle, opposite divided by hypotenuse. Opposite is minus 4 divided by 5. Why don't I take, do you understand why is it minus 4? Because y-axis in this quadrant is negative. It doesn't matter whether it is third or fourth quadrant. Y-axis, y values or opposite side is negative. Okay, so yet another way of thinking about it, notice the answer is sine negative 4 over 5. Okay, so the graphs were just saying that the sine is negative in between 180 to 60 because it's below the axis, below x-axis. So in this next question, we've been asked to write this, given that sine is 2/5, sine theta is 2/5, find the obtuse angle theta and find cosec theta. So we've been told that this 2/5 is obtuse. It's in the second quadrant here. 2 is the opposite side of, let's draw the triangle, and we always put the angle next to the x-axis, not the y-axis. Some people, if they're new, so this uh, angle, this triangle here, he's saying as opposite side is a 2, yes, positive 2, and hypotenuse is a 5. Use Pythagorean theorem to figure out the adjacent side. So what is the obtuse? Oh, sorry, we are not looking for an obtuse angle. We're just simply looking for cos theta. All right. So we need to know what's this adjacent side. This is square root of 5 square minus 2 square, which is a 4. Now that's the square root of 25 minus 4, which is 21. So adjacent side is 21. I can write those as, but oh, and don't forget x values are negative here, right? So this has to be a negative. So it has to be negative root 21, negative on the outside of square root over 5. This is cos of theta. Okay? That's the whole point. Taking care of the signs makes the whole thing work. So minus root 21 over 5. Now in this last example, we have some algebra to do. Given that p is 3 cos theta and q is 2 cos theta, 2 sine theta, show that 4p squared plus, oh, show that means don't worry about this for now. Okay, this is going to be our result, and we have to use our mathematical assumptions to work with this value of p and q. Alright, so what do we know about trigonometric identity from the top here? Tells us if I somehow square both sides, square both sides of this equation here, I'm going to get the cos square, and square both sides of this second equation, I'm going to get a cos square. So I'm going to just copy that 3 cos theta here, and I'm going to say I'm squaring both sides. This is something you're allowed to do in maths. You square, I'm not writing square properly, but here we have p square equals to 9 cos, cos square theta. And the second one is q equals to q sine theta. I'm squaring both sides again. I'm going to get q square equals to 4 lots of sine theta square. Okay? And if I add p and q together, what do I get? I'm not going to get 36, but alright, let's go and say uh, divide both sides by, actually we can divide both sides by 9 here, okay, Alright, p squared over 9 is cos square, and q squared over 4 is sine square. Right, because we want to use our famous identity up there. Alright, I'm gonna bring it down here and write now. I'm just gonna write the identity to you first and then substitute it. So this means that p squared over 9 plus q squared over 4 equals to 1. Alright, it's not looking like that yet, but we can cross multiply our fractions here. When we add in fractions, 4p squared plus 9q squared equals to 30 over 36 equals to 1. Now we multiply both sides by 36, and 4p squared plus 9q squared will be 36 as we require. Okay, so here is times by 36 is just adding fractions, cross multiply. Okay, you should do together common denominator. Okay, so I hope you enjoyed this video. I'll see you in the next video.